Okay, so this question's fairly straightforward, so I'll go through it rather quickly. We get given the 28 at the start. We know that tangent lines from the tangent point over to a common point, they're going to be of the same length, and we also know where they meet a radius, which I've just drawn. They will end up making an angle of 90 degrees. Because they make angles of 90 degrees, being supplementary, that means that these are supplementary also to end up equaling 360 within a quadrilateral. Therefore, 180, take the 28 that we started with, gives us 152. Because we have that 152 and the 290s, we'll figure out the size of Q, which Q will therefore just be 28, because it'll be 180 take 28. 180 take 52. 152 equals angle Q equals 28 degrees. And then quite simply, the angle at the center is going to be double the angle at the circumference with our little arrow shape thing here of RSPO quadrilateral. Therefore, S will have to be half of 152. 152 over 2 equals 76 equals angle S. And that's all we have to do for that question there. For this one here, we've got angle B is 17. So I'm going to do a little line there. I'm going to say equals 17 degrees. Angle C is going to be 51 degrees. And theta is 134. Prove by contradiction that D is not the center of the circle. So I guess what we're doing, we're really just going about it as if D was the center of the circle and then seeing if everything else adds up. So for starters, because the angle here at the circumference is going to be, the center is going to be double what it is at the circumference, that means 134 divided by 2 gets us angle A. So angle A is going to be 134 divided by 2 equals 67. This also means that we should be able to solve now for angle D, because we've already got angles A, B, and C. Well, to be fair, you should be able to get angle D just straight away anyways. If theta is 134, then angle D is going to be 226. So angle D would be 226 because it's 360. Take 134 equals 226. And I guess we can see if this matches up with what we've already got with our A, B, C, D, to see if that matches up with the cyclic. Actually, it's not cyclic quadrilateral, it just is a normal quadrilateral, which would still add up to 360 degrees. Well, it should. Let's see if it does. We've got our 226 plus, actually we'll get rid of that. We'll just do the other ones first. We'll just say it's 360, take 17, take 51, take 67, and that will get us, 225, which is not the 226 that we needed for it to equal 360 all the way around. So it is clear that D is not the center of the circle because we've used quite common circle theorems and common fact, I guess, geometric fact about quadrilaterals that they must sum to equal 360 degrees. So therefore, this is proof that D must not be at the center of the circle, because when we've applied the circle theorem correctly, we do not end up getting 360 degrees around point D.